All right, let's tackle 12 and 13 now. These will be the last two questions for this video series. This is the back page here, and both of these have to do with the distributed property. There are lots of different ways, of course, to rewrite these expressions, but because I mentioned here that we want to use the distributed property, I'm looking for some very specific outcomes. Please note that there are no equal sign, which means there's no answer to this. You're not going to be able to tell me that x is 3 or z is some inequality or anything like that. We're just reorganizing the expression. So the one way they talk about this in class to help you get a grip on what we're doing here is, let's take this first question, 6 times the quantity of x plus 3. So you've got the number 6 here, you've got your parentheses here, and you're adding two terms together. One of those is an x, and one is a 3. So what are we looking at here? Essentially, you've got this x plus 3 group. So this group right here is some number plus 3. And you have 6 of those groups. So what you want to ask yourself, if I have 6 x plus 3's, then how many x's am I going to have and how many 3's am I going to have? A lot of you can answer that when I just ask you the question in your head. Well, I'd have 6 x's and I'd have 6 groups of 3, so 6 times 3 is 18. But mathematically, you can do the exact same thing. You can think to yourself, well, I'm going to distribute the 6 in to the first term and into the second term. So just like I explained out loud, I'm going to have 6 x's and 6 groups of 3's. I'm going to have 6 times x plus, this is a step that most often is forgotten, 6 times 3. A lot of the mistake that I saw, they would just do 6x plus 3 and forget to move the 6 into the other term, the second term, the 3 as well. If you were to do that, it would just be the equivalent of saying 6x plus 3. Essentially, I have 6 x's plus 3. But we don't. We have 6 x plus 3's altogether. So we have 6 3's as well as 6 x's. So we definitely don't want to be doing that. But here we can finish it off. We can say that's going to equal 6x plus 18. And that's the answer that I'm looking for right there. I did, for most classes, get full credit for this. And I don't have a problem doing that. I think for the advanced class, I did require that you finish it all the way. But from here on out, I absolutely do want you finishing through this all the way. Let's look at the other one here. 3 times the quantity of 2 minus 4z. So this isn't that different. The only difference is we're dealing with a negative number inside of the group, whereas before we had 2 positive numbers. Let me double check that again. 3 times the quantity of 2 minus 4z. So I'll do those in green. 2 minus 4 times some unknown quantity z. You don't know what z is, but you know you have negative 4 of them. And you definitely know that you have 2. So you start with 2 and you remove 4 times whatever z is. And you have 3 of that altogether. So we've got a lot of groupings here. Well, if that's all confusing, it's hard to come up with an analogy when you're dealing with the negative numbers. Often I like to think about debt, but regardless of the analogy, you can just remember that your 3 needs to go to the first term and to the second term. So that's going to become 3 times the first term 2 minus 3 times the second term 4z. And you can finish simplifying that up as well. But that's how you deal with those first 2. Now the second term 2 are kind of the same, except we're flipping the process. Whereas before we have a single term, x times some number. Remember, a term is anything that's separated by a plus or minus sign. So this expression is not separated by a plus or minus sign. Yes, there is 2 terms inside of this parentheses, but because they're grouped together, we consider this one factor. A factor being something that you multiply with something else to make a product. So the product of 6 times x and some other term, I apologize for that, it was my phone, 6 times x plus 3, that is one term right there. This all can be thought of as one term. Whereas over here we have two terms. And in some cases it's beneficial to be working in two terms. In some cases it's beneficial to have one term. So we want to be able to go back and forth. So how do we get to one term when we have this two term 8x plus 24? Well, you want to think about it kind of the same way I did before. I'm going to leave that up there actually. So we're given the problem 8x plus 24. And you want to think of, is there a number that if I were to multiply in, I would get 8x plus 24? And another way to think about it, is there a number that I can divide out evenly from both of these terms? And what should jump out at you, even if you're not fully sure of what you're doing, is the fact that there's an 8 in this term and there's a 24 in this term. And 8 and 24 have some numbers in common, the largest of them being the number 8 right here. So I can rewrite this, if you think about it this way, as 8 times 1 x. Let me get rid of that 1. I don't want that there. Let's just say 8 times x. Am I on the right color here? Plus 8 times 3. So here I have 8 times x, and here I have 8 times 3. This is a plus right here, sorry. And hopefully you can agree that this is the same as this. 8 times x is the same as 8x. And 8 times 3 is the same as 24. So these are equal expressions right here. They're really the same thing. But what it reveals is that there's an 8 here and an 8 here. In both terms there's an 8. So another way to write this is I can pull that 8 out of both terms. And then in parentheses I can write down what I have left. And so if I pull an 8 out of this term, I'm going to be left with just the x. If I pull an 8 out of this term, I'm just going to be left with a positive 3. So the answer is going to be in this form, and you can fill in the rest. Let's see. The last problem that we want to look at, is 6 plus 36z. So that's going to be 6 plus 36z. And again, we want to think, what do we have in common between these two terms? They're both even numbers, so 2 is in common. They're both multiples of 3. But more importantly, they're both multiples of 6, which is our largest common factor, our greatest common factor. So we can rewrite this as 6 times 1 plus, instead of 36, let's write it as 6 times 6 times z. And so now you can see that there's probably one number that I can pull out of both terms. And again, I want to get to this form right here. I want to get to a product. And so what are you going to be left with when you're done? And hopefully at this point you can finish this off. If you don't know where to go, how to get from here to here, then you can come and see me and we'll work it out. But definitely watch the video a couple times and see if it makes sense. Good luck.